Suppose that you had some function f of x and it was approximated near x equals 0 by a third degree Taylor polynomial. So they gave you p sub 3 of x equals 2 minus 5x squared plus 8x to the third, so that's third degree. And someone asked you to find, well, what was the value of the original function at x equals 0? Now keep in mind it was approximated near x equals 0, so this one is centered at 0, and you can see that because I have an x squared, not an x minus 1 in parentheses squared, etc. But find f of 0, f prime of 0, f double prime of 0, and the third derivative at 0. So what you could do, and there are lots of different approaches to take, but one thing you could do is just write the pattern out. Now this is f of 0, so we're going to say this is like Maclaurin, but I'll have the pattern for my third degree polynomial will be f of 0 times x minus 0 to the 0th over a 0 factorial plus f prime of 0 times x minus 0 to the first over 1 factorial plus f double prime of 0 times x minus 0 squared over 2 factorial plus f the third derivative at 0, x minus 0 cubed over 3 factorial. Now they actually gave us the polynomial, so I know that this is x to the 0th power, which is just a 1. So I know that the 2 term right here matches with this right here. The 5x squared goes with the x squared term, so I have 5x squared matches with this, and then the 8x cubed matches with this last term. So this term right here is actually a 0x to the first because it's not there. So what I know is that this is like an x to the 0 right now, but I know that f of 0 divided by 0 factorial has to equal 2. Well, 0 factorial is 1, so I multiply by 1 on both sides, and I have f of 0 equals 2. I know that my 0 is f prime of 0 over 1 factorial equals 0. Well, 1 factorial is 1, multiply it across, and I know that f prime of 0 has to equal 0. For this, I know that my 5x squared has to equal this whole polynomial, so 5 has to be equal to the coefficient. This x minus 0 squared and the x squared match up. So I know that f double prime of 0 over 2 factorial equals 5. So 2 factorial is 2, I multiplied, and my second derivative at 0 is 10. For my last term, I know that the third derivative at 0 divided by 3 factorial has to equal 8. The x minus 0 cubed and the x cubed match up, and these terms are the same. So 3 factorial is 6. So my third derivative at 0 will be 8 times 6, which is 48. So I was able to find the function value at 0, the first derivative at 0, the second derivative at 0, and the third derivative at 0. So then you might be asked, does f have a local max, a local min, or neither at x equals 0? Well, to determine that, the first thing that has to be true is your derivative has to be 0 at x equals 0. And we come up here and it is. What that means is that x is a critical number, and x equals 0 is a critical number. Now, I can't actually look at intervals on either side of the 0, like take a number line, here's my 0, let me check the values of my derivative to do the first derivative test. That doesn't work. So I'm going to switch to my second derivative test. The second derivative at x equals 0 is 10, and that means that my function is concave up. So I have a spot where it flattened out when it's concave up, and I have a minimum. So there is a minimum. At x equals 0. If they asked what the y value was, the y value is 2. But the justification for that would be that f prime of 0 equals 0, meaning that the graph does flatten out, that 0 is a critical number, and f double prime of 0 is greater than 0, which tells us that the graph is concave up. So we have a minimum. It's the second derivative test.